Everybody clear? 3, 2, 1.
Few of us will ever witness firsthand the ferocious energy of tornadoes, yet they're far from rare. More than 900 tornadoes touch down in the United States each year, leaving lost lives and billions of dollars of damage in their wake. Although less common and less potent, hurricanes are no less devastating. In 1992, Hurricane Andrew caused more than $20 billion of damage in South Florida, and no coastal area is exempt. Most losses are not because of wind itself, but the debris it carries. And here in the heart of West Texas tornado country, Texas Tech University developed a new test to simulate the impact of wind-driven debris on homes. Dr. Ernst Kiesling of the school's Wind Engineering Research Center explains.
The greater threat to life is the flying debris. We know of relatively few instances where people are actually crushed due to falling buildings and so forth.
Dr. Kiesling and his colleagues are measuring the performance of wall systems under tornado conditions. With a device called the tornado cannon, researchers duplicate the effects of flying debris by firing a 15-pound 2x4 at more than 100 miles per hour, the speed at which it would be carried by a 250-mile-per-hour wind. A 250-mile-per-hour wind speed covers 99% of all tornadoes and 100% of all hurricanes. And of all the wall types tested to date, only concrete systems have the mass and hardness to withstand these tests. A recent series of tests compared the performance of 3 common wall systems for home building. First, conventional wood frame construction, the kind used in nearly all homes. This wall is the standard. 2x4 wood studs on 16-inch centers with 3/4-inch plywood sheathing. Vinyl siding covers the exterior, and drywall provides the interior finish. Once in the test frame, the wall is ready.
3, 2, 1.
This is typical of traditional wall sections. There's simply not enough mass or hardness there to prevent perforation. So the missile simply perforated, went all the way through, and did considerable spalling on the backside.
Next, the same type of wood stud wall with brick veneer.
Certainly this masonry adds some mass, yet I would not expect it to be successful in repelling the missile simply because there's not enough connectivity among the masonry units.
2, 1.
We saw in this masonry with the stud wall section the missile perforate completely, despite the fact that the speed was only about 70 miles per hour. It would not take a severe tornado to carry a missile at 70 miles per hour.
Like other lightweight building systems, steel stud walls lack the mass and hardness to withstand the impact.
3, 2, 1.
This wall section that used the 4-inch steel studs simply did not have sufficient mass or hardness to withstand the impact of the missile. The missile splintered only when it hit the back wall of the laboratory.
Mass and hardness are not issues for concrete. The tests at Texas Tech began with 2 conventional concrete wall systems, a solid cast-in-place concrete wall and a concrete block wall. Wood fibers embedded in the concrete are the only sign of impact. The next series of tests involved a relatively new type of concrete wall called insulating concrete forms, or ICFs. Individual ICF products vary, but all share some common traits. Blocks or panels of polystyrene are stacked to form walls. Reinforcing steel is added, then concrete is pumped into the center cavity. The forms are left in place to serve as insulation. The finished wall is a core of reinforced concrete with foam insulation on each side. The first ICF wall has a 6-inch thick solid concrete core with a brick veneer.
3, 2, 1.
This is what we like and expect to happen. While there is some superficial damage here, didn't perforate the wall at all. So this is the desired behavior.
The next ICF system is also formed with blocks of foam. The core is a continuous 5-inch thick concrete wall.
3, 2, 1.
Again, damage was confined to the vinyl siding and the foam beneath it. The concrete wall itself is unscathed. Another test on the other side of this wall confirms its solid performance. Even at a missile speed of 120 miles per hour, there is no damage to the concrete wall. The third type of ICF wall tested has a 4-inch thick concrete core.
3, 2, 1.
This wall, again, performed excellently. The missile impact was at this location right here. We removed some of the insulating material simply to get a closer look at the concrete. But in exposing the concrete wall, we see no damage whatsoever.
Of special interest were waffle slab walls. These types of ICFs use a posted beam configuration rather than a solid continuous wall. The thickness of this wall varies from 2 to 6 inches.
From a structural standpoint, certainly this is more than adequate. For missile perforation, we will try to hit it at the thinnest section.
3, 2, 1.
At this point, I can see no signs of damage structurally. This is the second shot on this waffle slab. The missile impacted at this point exactly where we wanted it, halfway between the horizontal beams and the vertical columns.
What do these tests mean for safer homes and reduced property damage? Only concrete has the strength, hardness, and mass to provide built-in safety.